A few moments later. A few moments later.
Right, we're back with question 2. My load of washing finished, so you've got me now. Okay, so this is the original function, and this is the differential function. So notice here there's a f dash of x versus f of x. Okay, so we want to look for the turning point. So the turning point is there and there. So in other words, our graph is for the first derivative is going to cross the x-axis there directly below it and about there directly below it. So this has two humps, so our difference is going to have one hump. So it's negatively sloped there, so it's going to sort of look kind of like a parabola, yes. Yeah, it's going to get less and less and less steep. And sort of point of inflection is there, and it's that one there. That's that. That's just how it is. Okay. Find the equation of the tangent to the graph. F of x is 3 minus 12x plus 3x cubed. I wonder if this is the same graph. Okay. At the point minus 2, 3. Okay. So they want to find the tangent at that point. So in order to find the tangent, we need to find the slope. So if f dash of x, if f of x is that plus 3x cubed, then f dash of x, when we differentiate that, 3 is going to go minus 12 plus 9x squared. So then they want to find the gradient when that equals minus 2. So plus 9 times minus 2 squared, and minus 12 plus 36. So that's going to be 24. The gradient is going to be 24. So m is going to be 24. So we know the gradient and we know one of the points. So we can use our y minus y1 equals mx minus x1 formula for that. So y minus 3 is going to be equal to 24x. So minus and minus is plus 2. So y is going to be equal to 24x plus 48 plus 3. So that's going to be 24x plus the 51. That's going to be our final answer. Yeah. Right, so a microbiologist, so you know something evil is going to happen, is growing bacteria in a petri dish in a lab, okay, and monitoring the population of bacteria in the dish. So in other words, a microbiologist is getting an undergrad to count the number of bacteria in a dish every day. After a certain number of days, the bacteria colony will have used up all of the nutrients in the petri dish. At this time, the population will be at a maximum and it will begin to decrease. In other words, bacteria are going to start dying. When the microbiologist adds more nutrients to the petri dish, like some evil overlord, the population of bacteria will begin to increase again. Okay, all other things remaining equal, the microbiologist thinks that the population can be modeled by this equation. There, okay. There's probably a Taylor series of exponential growth, but where P is the population of the bacteria and T is the number of days since the sample was prepared. What is the rate at which the population is decreasing on day 10? Okay, so we're looking at change, so we're going to need to differentiate this. So one thing I'm going to do is just pause there, and I'm going to put this into the calculator so I can see what it looks like. A microbiologist, oh no, there's going to be some things dying, is growing bacteria in a petri dish in a lab. Biologists are bad, microbiologists are even worse. Monitoring the population of bacteria in the dish, or in other words, some microbiologist is getting a undergraduate to count the number of bacteria in a dish once a day. Good luck with that. After a certain number of days, the bacteria colony will have used up all of the nutrients in the petri dish. So our microbiologist is playing as a god complex. Okay, at this time the population will be at a maximum and will then begin to decrease. Okay, in other words, they're going to start dying. When the microbiologist, so a biologist, a really tiny biologist, a microbiologist, adds more nutrients to the petri dish, the population of bacteria will begin to increase again. So this monster is going to starve them to death and is then going to start giving them sugar water so that they start multiplying. The microbiologist thinks the population could be modeled by this equation, which is probably a Taylor series approximation, where P is the population of bacteria and T is the number of days since the sample was prepared. At what is the rate at which the population is decreasing on day 10? So we're wanting a rate, so we're going to be differentiating. Why they give you this backstory, I don't know, but okay. So we know that PT is this, and I always get criticized by people. I rewrite the formula, but it's just actually really, if you can hear that, that's my washing machine on the spin cycle. So T cubed is this, and we want the change. So we want change in the population. So it's going to be 3t squared minus 120t plus 768. And we're going to put in 10 in there. We're going to get the following: squared minus 120 times 10 plus 768. Going to get some number. Going to get Mr. Casio to calculate that for us. So 10 squared is 300. So 300 minus 1200 plus 768. So minus 132. So minus 132. So that tells us that there are approximately 132 bacterium, I think is the singular, die each day. And only you can stop this microbiologist from killing these bacteria who have done nothing to her. Okay. Sorry, I have a thing. So use calculus methods to determine the difference in bacteria population size from the time all the nutrients in the petri dish are used up to the time the microbiologist added more nutrients. Okay, so I'm going to pause there and I'm going to put this in the calculator because I want to know what it's going to look like. My guess is that it's going to sort of start here at what, 40,960. It's going to go up and then she's going to stop feeding them, they're going to start dying, and then she's going to start feeding them again, so it's going to go up like that, and it's to the power of 3, so it's going to kind of look like that kind of N letter. So I'm just going to pause the video and set it up on the calculator. We're back. So I put it in the calculator and got it to draw, and sure enough it does kind of look like that lazy N thing. I put it on pause because I'm sure you don't want to watch or listen to some old guy clicking numbers. So there we go. So it's going to, there's going to be a maxima here and a minima here. Okay. So we want to know what that is. So we're going to take this first derivative and we're going to set it equal to 0 to find out what the turning points are. So 3t squared minus 120t plus 768 equals 0. And I think these all, they're all going to be multiples of 3, aren't they? So having said that, you probably don't want to listen to me bettering on. So 768 divided by 3 is 256. Okay, so they do. So if we divide both sides by 3, which is good because 0 divided by 3 is still 0, we get t squared minus 40t plus 256 equals 0, and I'm no idea the multiples of 256. So I'm going to calculator again. Okay, we're back. I just had to remind myself how to do these. So I'm going to put this in. Actually, I'll put in the original equation here so you can see how it works. So I went to equation F2 for polynomial solver. It's a degree 2 because it's to the power 2. So I'm going to put in 3 minus 120, 768, all entered, and 32 and 8. So in other words, this is day 8 and this is day 32. So this monster microbiologist watched and gleefully laughed at these 24 days while these bacteria slowly died. Okay. Take a breath. Okay. So 8 and 32. Now 8 is a maxima, 32 is a minima. So we're going to put in 8 squared minus 40 times 8. No, we're not. We're going to go to the original equation, aren't we? So the original equation is this one up here. So 8 cubed minus 60 times 8 squared is 64 plus 768 times 8 plus 40,960. No idea what that is off the top of my head, so calculator time again. Right. So 8 cubed is apparently 512 minus 60 times 4 plus 768 times 8 plus 40,960 is 43,776. Okay, and then on day 32, so it's going to be 32 cubed. Oh, it's going to be a huge number. minus 60 times 32 squared plus 768 times 32 plus 40,960. Okay. Calculate for that. I definitely just, well, 32 cubed is some horrendous number. 60 times 2, 32, safe side, plus 768 times 2 plus 4960 or 36,864. That's how much we had. So the difference here is how many bacteria our evil overlord microbiologist killed. So the difference is going to be could have just subtracted it, but there you go. 43,776 minus 36,864. So 6912. I think bacteria is the plural, bacterium is the singular. So if you get like one kind of bacteria there, the cell, the nucleus, that's one bacterium, I think, or bacteria. In any case, I'm not going to ask a microbiologist because they tend to kill all of these things. And they say we do that. Here we go with the next question. So trapezium is drawn within a parabola. Okay, so this parabola. Y equals 8x minus x squared. So that's that parabola there. And the x-axis and such that two parallel sides. So these are parallel. Okay. I position x and 2x as shown in the graph below from 0 to 4. Okay. Given that the area of this trapezium, the area is half a plus b times h, which is the height, where a and b are lengths of the parallel sides, and h is the perpendicular distance between them. Okay, so that's distance here. It's h. Use calculus to find the maximum area of the trapezium. So before Leibniz and Newton came along, this was a pretty standard way of estimating the area under a curve. So one observation straight away is that 2x minus x is the x. So h must be equal to x. So that simplifies things a little bit. And we know that a is x and this is y of x and b is y 2x. Okay, so that's going to be, we'll just put an x in where there's an x, so it's going to be 8x minus x squared, I guess. And this one here is going to be 2x minus 2x all squared, so that's going to be 16x minus 4x squared, I think. Yeah, that makes sense. So that's going to be that part. And then this is going to be, that's going to be A, and that's going to be B. Okay, so the area is given as half A, which is 8x minus x squared, plus 16x minus 4x square times x. because h is x. So now we have one equation with one variable, even though it's raised to a power. Let's just simplify it a little bit. So half x, let's combine the half and the x, and then minus 5x squared, so that's done, plus 24x, that's that done and that done. And now let's expand out the brackets, so multiply the outside to the inside, so it's going to be minus 5 over 2 x cubed plus 12x squared, and there's no other term. So that's our area in terms of x. Okay, so that's the area, and we want to maximize. What do we want to do? We want to maximize, maximum value. So we want to differentiate that. So we want to differentiate a with respect to x, and that's going to be 5 stays there. Now it's going to be 15 over 2 x squared, so the 3 comes down here, plus 24x, the 2 times the 12 goes is 24x. So that's that done, and we want to find the turning point, so we're going to set that equal to 0. There's going to be two solutions here. One is probably going to be a maxima, and one is probably almost definitely going to be a minima. And it's going on so long, it's actually interrupting the next question. So we want to set that equal to 0 and solve x. Well, let's factor out an x there. And that's just going to make our life a lot easier. So we know from that one of the solutions is x equals 0, and that must be a minima. Okay, because if we come back to our original equation here, our original problem, if x was 0, then the area would be 0. It would just be a point. So that must be a minimum. So when we set negative 15 over 2x plus 24, if I missed a 24x, is there an x that I've missed there? Oh, there's going to be a square there, isn't there? Yes. Squared. No. Hang on. Grab that. So we've got that. And we factored out the x. So 15x plus 24. Okay. Okay, yeah, that makes sense. So I was right. So I'm going to take 24 away from both sides, so it's negative and negative. So minus 15 over 2x equals minus 24. I'm going to cross multiply now. So minus 15x equals minus 48. So x must be negative 48 over negative 15, which is...
A few moments later.
Into it. So 48 divided by 15 is going to be 3.2. That makes more. So x is 3.2 is going to maximize that area. So when x is 3.2,
A few moments later.
our area is, well, what did we say area was? It's going to be that one there. So it's going to be minus 5 over 2, 3.2 cubed, plus 12, 3.2 squared, and it's going to give us some number. It gives us something strange. We know that something strange is going on. I'm a bit worried about this calculator, actually. So,
A few moments later.
Minus 5 over 2. Just being really paranoid now. Plus brackets 12. I'm putting in just way too many brackets. 40.96. That seems about reasonable. So what's the units? So it's doesn't give us the units. So the maximum area is 40.96 when x equals 3.2. Fair enough. Okay. Find the coordinates of the point on the graph of this function above where the gradient is equal to 3. Okay, so we're looking for the gradient. So we're going to differentiate it and we're going to find out what x equals when we set that equal to 3. So our original function is 0.25 squared minus 2x plus 4. Don't complain, I'm writing down the equation again. So 2 times 0.25 is 0.5x minus 2, and the 4 disappears. Gradient. Okay, and we want to set that equal, so that's dy dx, and we want to set that equal to 3 and find out what x is. So 0.5x equals 5. I add 2 to both sides, so x is going to be equal to 5 over 0.5, which is 10. So this one is going to be 10, and then to find the y coordinates we're going to put in 10 in here. So 0.25 is 10 squared, so that's going to be 25 minus 2 times 10, which is 20, plus 4. So it's going to be 25 minus 20 plus 4, which is going to be 9. So it's going to be at the point 10, 9 is where the gradient is going to be equal to 3. That's that done. Right, so a truck is waiting in a red traffic light. Yep. When the traffic light turns green, the truck begins to accelerate at 0.64 meters per second until it reaches a top speed of 25 meters per second. Use calculus to find the distance the truck traveled until it reaches top speed. So those of you who do physics will know that this is already done for you with the kinematic equations, but we need to do it from first principles. So we're given that the acceleration is 0.64 and we don't know what the time, so that's irrespective of what the time is. So we need to know how long it's going to take to get to 25 meters per second. Well, velocity, so it's going to be 25. So we start at 0. It's going to be 25 divided by 0.64. So every second it's 0.64 meters per second faster. So that means that the time is going to be 25 divided by 0.64, which I don't know off the top of my head. $30.0625, 39.0625, and that's going to be seconds. Okay, Okay, and what do we do? So we know, okay, so we know that velocity is when we integrate the acceleration with respect to time. And we know that the initial velocity at time equals 0, is 0. So the constant term will be 0 at the end there. So when we integrate 0.64, because the acceleration is the same, we're going to get 0.64 t plus 0, because 0 is our initial condition. We also know that when we integrate the velocity with respect to time, we get the displacement. I'm going to say displacement is s, so we don't confuse this d here with the distance there. And that means that when we integrate 0.64 with respect to time, and we know that the initial velocity, the initial distance is also 0, so that's our constant term taken care of. So the distance is going to be 0.64, that stays. The t stays there. We get a 2. We divide that by 2 and the plus 0 at the end there. And then for our t, we're going to put in this here. So we've worked out the kinematic equations from first principles then. So this is going to be 0.64 times 39.0625 square, all divided by 2. And that's going to give us some number. Let's clear off the last question. So 0.64 times 39.0625 square equals that. Divide that by 2. 488. So that's 488.28125, and the unit is meters per second. So let's just call this 488.3 meters per second. I'll give you that 2 centimeter per second head start, and that's our final answer on that. So I'm going to circle that as our final answer. Okay, next one. Shown on the graph below is the gradient graph. So it's not f of x, it's f dash of x. You can't quite see that, but this is f dash of x, and this is x. So find the equation for x which passes through the line 1, 0. Okay, so if we start at f dash of x and we want to get to f of x, we're going to need to integrate with respect to x. So our original equation, well, the equation we've got there, we don't know, but we can kind of work it out. It's a straight line, so it passes through, so it's something plus 1, and then 2 across, 1 up. So half x plus 1 is our first derivative, and if we want to find f of x, we're going to need to integrate that. So it's going to be, the half is going to stay there, x is going to stay there, that's going to go by 2, and then we're going to divide that by 2 plus x. So half, so that's going to be, what's that going to be? That's going to be 0.25 x squared plus x plus c. We don't know what that c is, but we can work it out because we know that when x equals 1, y equals 0. So I'm going to find that now. Half divided by 2 is a quarter. Yes, that's right. Yeah. And we know that that's going to be 1 squared plus 1 C equals 0. That's going to be 0.25 plus 1 plus C equals 0. Have I done that right, actually? I'm going to just pause because I think I made a mistake. Nope, I checked it and we're all good. So C is minus 1.25. So our original equation f of x is going to be 0.25 x squared plus x minus 1.25. If that's wrong, let me know. I think that's right. Wrong, I'm not sure. Okay, let's just move on. MoveOn.com. Right, we're almost done. Almost done. The end is in sight. So we want to graph this graph now. Well, we know it's going to be a parabola. Is the number in front of the x squared is a positive number, and we know it's going to cross the y-axis. The y-intercept is going to be at minus 1.25. So around about what? There, somewhere. So now we need to find the turning point and the roots, the y-intercepts. So to find the turning point, we're going to differentiate, but we don't really need to differentiate because if we're already given f dash of x, and we work that out to be half x plus 1. So we're going to set that equal to 0 and solve. Okay, so half x equals negative 1. X is going to be equal to negative 2. So our turning point is going to be somewhere under that negative 2. So it's going to sort of go like that. Okay, so now wasn't good. So now that we've got that, we'll put a negative 2 into our original equation and find out what y is. So 0.25 negative 2 squared plus, it's going to be minus 2 minus 1.25. So 0.25 times 4 is going to be 1 minus 2 minus 1.25. It's going to be minus 2.25. So it's going to be minus 2 and then minus 2.25 about there. So we know two of the points that it's going to go through. We know the turning point, we know the y-intercept. Now we need to find the roots. So to do that, how are we going to do that without completing the square? And we're going to set that equal to 0, and then we're probably just going to be lazy and just use the calculator, to be perfectly honest. The way you'd solve that, you'd need to complete the square. So yeah, polynomial solver 2. Okay, so it's a polynomial of degree 2. 0.25 is the coefficient in front of the x squared. The coefficient in front of the x is 1, and the coefficient in front of the constant coefficient is 1.25. Well, it's not coefficient, but the constant is negative 1.25. I'm going to put that in, and it's going to give us two answers, 1 and negative 5. So we know that it's going to go through this point here and this point here, and that's our minimum. So it's going to kind of go sort of like that. Again, I'm not an artist, so it's at negative 2, negative, what do we say, negative 2.25, 1, and 5, and that's it. That's pretty much all we need to do. Well, hello from a very, very cold, wet Wellington, the end of a very long winter. This video follows the NCEA L2 algebra exam. This is the second part, the NZQA NCEA L2 Calculus. It's kind of intro to calculus using polynomials. So in this video, we're going to do this only using the technology in the syllabus of a year 13, year 12 student would know. Some of them you could use multivariable calculus and other tools, but I'm only going to differentiate and integrate. And most of them, I think all of them, are just polynomials. So we're just going to be using the power rule, where if y is a x, do that again, y is a x to the power of n, then dy dx is going to be n times a x n minus 1, and when we integrate it, the a stays there, the x stays there, the n gets one bigger, and we divide by n plus 1. So that's pretty much all of the calculus that we're going to use, and I'm going to be using just the stock standard Casio FX calculator. This is a pretty old model. I don't even think they make this model anymore. I think they're up to like series 4 or something, but this will do the trick. Okay, so I haven't gone through the exam before. I've had a quick look at it, obviously, when I was cutting and pasting them on here, but this is my first look at it. So function f is given by f of x equals 3x minus 6x squared plus 5x plus 2. Use calculus, okay, to find the gradient where x equals 2. So they're telling us here they want the gradient, so they want us to differentiate it. It's a nice polynomial. So if, actually they give it to us an f. If f of x is this, 4x cubed minus 6x squared plus 5x plus 2, we differentiate that, we're going to get 12x squared minus 12x plus 5, and then they want us to know the gradient where x equals 2. So we're going to put in 2 in this case, squared minus times 2 plus 5. So it's going to be 12 times 4 minus 24 plus 5. So that's going to be, well, it's winter. 12 times 4 is 48, minus 24 plus 5 is going to be 29. So the gradient is going to be 29. I guess we could put 29 over 1 really if it's a gradient. And I think that's all they wanted. Yes, I think that's all they wanted. Let's move on. Alright, so for this one, they give you the differential. They give you f of x, f dash of x, and they want f of x. And it goes through this point 2, 36. Okay, well, if we start at f dash of x, and we want to get to just f of x, we're going to need to integrate with respect to x. So if this is f of x, f dash of x is 12 minus 4x plus 6x squared, then f of x must be 12x minus 4x squared over 2 plus 6x cubed over 3 plus c. And let's just tighten it up a little bit. So 12 should be 12x. 12x minus 2x squared plus 2x cubed plus c. So we don't know what c is, but we've got a big little help there, and it tells us that when x equals 2, y equals 36. So we can use that to solve for c. So let's plug in the 2. So 12 times 2 minus 2 squared plus 2 cubed plus c equals 36. Okay, so it's going to be 24 minus 8 plus 2 cubed is 8 times 2 is 16 plus c equals 36. And let's solve that. So 24 minus 8 plus 16 is 32. 32 plus c equals 36. So therefore c must equal 4. So our full equation, f of x, is going to be 12x minus 2x squared plus 2x cubed plus 4. And there's our final answer. All right, next one. A curve is given by 3x cubed minus 9x squared minus 27x plus 4. Using calculus methods, okay, we get the point. Find the x coordinate of the local minimum. Okay, so if we find a maximum or minimum, we're going to be differentiating. And explain how you know this is a minimum point. So we're going to be differentiating again to find that. Okay, so let's take the original equation. So y equals 3x cubed minus 9x squared minus 27x plus 4, and dy dx is therefore going to be 9x squared minus 18x minus 27. Then I'm going to differentiate that again. So I'm going to get 18x minus 18, and that's going to become important a bit later on. Until then, let's take this one. We want to find the turning point, so we're going to take this one. We're going to set it equal to 0. Now I can see something interesting here. These are all multiples of 9. So I'm going to divide both sides by 9. The good thing about that is 0 divided by 9 is 0 still. So we get x squared minus 2x minus 3 equals 0. Now it's a lot easier to manage. So we want two numbers that multiply to give us -3 and add to give us -2. Well, it's going to be x minus 3, x plus 1. -3 times positive 1 is -3. -3 plus 1 is negative. Yes, that's right. Okay, so x minus 3 equals 0. So x equals 3. And x plus 1 equals 0. So x equals -1. So we know that there's a turning point when x equals 3 and when x equals -1. Now we want to know which one is the turning point. Which one is the minimum point. So this one now comes into play. So let's put in 3. So 18 times 3 minus 18 is some number, but it's a number which is greater than 0. So therefore that's a minima. When we put in this -1 business, so 18 times -1 minus 18, that actually equals, no, it's less than less than 0, so that's a maxima. I thought they're negative 18. Yeah, they thought they cancelled out, so that's a maxima. So it's a minima where x equals 3. Now that's not quite what they asked. They've wanted the x coordinate. Okay, so I guess that is what they asked. But if we put that into the calculator and we wanted to find that point, we would find it by putting 3 in there. Minus 3 squared, that's the worst 3 ever written. Minus 27 times 3 plus 4, and I'll leave you to do that. But that's that one, and that's how it's done. So we differentiated it first to find where the turning points are, and then we differentiated that again to find out whether it was a maxima or minima point. If it's greater than 0, it's a minima. If it's less than 0, it's a maxima. This x equals 3 was the only one that met the criteria, so x equals 3 is what it is. Alright, moving right ahead. I had to pause the video there. My washing machine went into its spin cycle. I don't think you want to hear that. So this one, by the looks of it, is going to need a lot of space, so I'm going to give myself a lot of space. So a drink manufacturer would like to start a new line of cylindrical cups, okay, good for them, that are designed to keep hot liquids warm for as long as possible. Why do they give you all this information? To do this, they wish to minimize the surface, area of the new cup, which includes a lid, okay. They would like the cup to hold a volume of 500 mils and be cylindrical in shape. Okay. Calculate the dimensions that would satisfy the above conditions. There's that. Okay. So the first thing is they want you to minimize it, so you're going to be differentiating. So at some point you're going to be differentiating that. And there are two variables here, R and H. So we could do it using multivariable calculus, but we're not going to do that because they're linked anyway. So they want the volume to be 500 mils. Now I suspect at some point, I'm going to have a look now. I suspect they're going to tell you that 1 mil is actually equal to 1 cubic centimeter, because these are in centimeters. Well, are they in centimeters? They must be pretty bloody big cups if they're in meters. So I'm going to presume that that's in centimeters. I'm just going to pause the video because I'm just going to sort of check. So I think 1 mil is one cubic centimeter. Okay, we're back. I just checked, and no, they don't actually tell you that 1 mil is 1 cubic centimeter, but it is 1 centimeter. It messes with your head in chemistry. They want everything in decimeter cube, but it's a real pain in the neck. But 1 mil is 1 cubic centimeter, therefore 500 mils is going to be equal to 500 centimeters cubed. So now these H and R are going to be in centimeters. That's the unit. So the volume is this. Okay, yep. And the surface, which is the thing we wanting to minimize, is this. So therefore, let's get rid of one of these variables. And R is in both of those, so we'll get rid of H, I think. So the volume is going to be 500, and it's going to be pi R squared H. So H, therefore, is going to be 500 over R squared. Is that right? Yeah, that makes Okay, then when we've got that, we can sub that into this equation, and now we're going to have one equation with one variable, and then we can differentiate that just using our standard differentiation. So the surface area that we wanted to minimize, you see, let's just call it area, is going to be 2 pi squared plus 2 pi r, and then times this new thing here, r squared. And I think this is going to be quite nice when it cancels. So it's going to be 2 pi r squared plus 2 pi r times 500 over pi r squared. And I'm going to lose pi, and I'm going to lose one of the r's, and I'm going to be left with 1000 over r. Whoops. Plus 1000 over r, and I'm going to rewrite it so that in differentiate it as if it's a polynomial really easy. R to the negative 1, so 1 over r is the same as r to the power of negative 1, remember. So I've got the surface area now in terms of r. Now I want to just differentiate it, so I want to differentiate the area with respect to the radius, and I get 4 pi r minus 1000 r power negative 2. Yes, that would be right. Yep, that makes sense. So we want to set that equal to 0 and then solve. So how are we going to do that? So 4 pi r must be equal to, and I'm going to put this back over r squared like that, because I added 1000 over r squared to both sides, and then I'm going to cross multiply. So this is over 1, so r squared is 4 pi r equals 1000. Yep, so 4 pi r cubed equals 1000. So therefore it follows that r cubed must be equal to 1000 divided by 4 pi. So r must be the third root of 1000 over 4 pi. Oh, I'm just glad I gave myself a lot of room. So I don't expect anyone to know that off the top of their head, so let's grab the calculator. So I'm going to do it like this. So 1000 over 4 pi, and then I'm going to raise it to the 1/3 power, which is the same thing as finding the third root. I just prefer it this method. So the cube root of that is 9.22. All right, 2000 over 4 cubed. Oh, pays to check. So I thought that must be it. That's pretty big. So I'm going to find 1000 divided by 4 pi. That's that. And then I'm going to find the cube root of that. .3. I'm going to use that one because I think that sounds a bit more real. So the R is going to be 4.3. Yeah. 4.3013. Okay, so now we have R. Now we can go back to our original equation and this, oops, this one here, and we can find what H is. So H is going to be the 500 equals pi r squared h. We want to solve for h. So therefore h is going to be equal to 500 over I times 4.3013, and I'm kind of leery of using this calculator now. It's going to be some number. Okay, so 500 divided by pi times the last answer squared, 8.6025 centimeters. Okay, so now we know what R is, we know what H is. Calculate the dimensions of the cylinder that would satisfy the conditions. Okay. Well, when we do the cylinder, again, I'm not an artist. So the radius there is going to be roughly 4.3 centimeters, and the height here is going to be roughly 8.6 centimeters, and that's going to give us the dimensions that we're after. So the volume is going to be 500, and the surface area is going to be minimized. So imagine if you're making millions and millions and millions of these things, any kind of slight efficiency is going to be worthwhile. All right, we're almost done. Almost done. The end is in sight. So we want to graph this graph now. Well, we know it's going to be a parabola, because the number in front of the x squared is a positive number, and we know it's going to cross the y-axis. The y-intercept is going to be at minus 1.25. So around about what? There, somewhere. So now we need to find the turning point and the roots, the y-intercepts. So to find the turning point, we're going to differentiate, but we don't really need to differentiate because if we're already given f dash of x, and we work that out to be half x plus 1. So we're going to set that equal to 0 and solve. Okay, so half x equals negative 1. X is going to be equal to negative 2. So our turning point is going to be somewhere under that negative 2. So it's going to sort of go like that. Okay, so now wasn't good. So now that we've got that, we'll put a negative 2 into our original equation and find out what y is. So 0.25 negative 2 squared plus, it's going to be minus 2 minus 1.25. So 0.25 times 4 is going to be 1 minus 2 minus 1.25. It's going to be minus 2.25. So it's going to be minus 2 and then minus 2.25 about there. So we know two of the points that it's going to go through. We know the turning point, we know the y-intercept. Now we need to find the roots. So to do that, how are we going to do that without completing the square? And we're going to set that equal to 0, and then we're probably just going to be lazy and just use the calculator, to be perfectly honest. The way you'd solve that, you'd need to complete the square. So yeah, polynomial solver 2. Okay, so it's a polynomial of degree 2. 0.25 is the coefficient in front of the x squared. The coefficient in front of the x is 1, and the coefficient in front of the constant coefficient is 1.25. Well, it's not coefficient, but the constant is negative 1.25. I'm going to put that in, and it's going to give us two answers, 1 and negative 5. So we know that it's going to go through this point here and this point here, and that's our minimum. So it's going to kind of go sort of like that. Again, I'm not an artist, so it's at negative 2, negative, what do we say, negative 2.25, 1, and 5, and that's it. That's pretty much all we need to do. Okay, this one. So I had a look at this one, and I cut and pasted it, and I thought, oh, this has the potential to be nasty. So how are we going to do this? Well, I'm going to say I'm going to make this thing Z. Okay, so Z, we're wanting to minimize Z, and we want to prove that that is our negative, our value. Well, we have x and y, so we want to get rid of one. So I'm going to get rid of the y because it's kind of already done for me. I've already got y in terms of x. So I know that z is going to be x squared plus 2k minus x squared. So I'm going to park that for later. So I'm going to expand out the brackets, and I'm just going to do it kind of old school. So you can see the machinery at work. And so k minus x, k and minus x, that's k squared minus kx minus kx. It's going to be x squared, and when we complete it, we've got k squared minus 2kx plus x squared, and then we're going to multiply all of that by 2. So we've got 2k squared minus 4kx plus 2x squared. And remember, k is a number. It's a real number. So when we differentiate it, we treat 4k as a number. So our final argument here, our final equation, is going to be plus, going to be our final equation, minus 4kx plus 2x squared. And so that's z in terms of x and k. So now I want to differentiate z with respect to x. So I've got 2x. 2 times a constant squared is just a constant, so it's going to disappear. Minus 4k. Plus, and I could have combined those terms. Plus 4x. Okay, so I combine these like terms. It's 6x minus 4k. Okay, so we've differentiated it, so now that's going to tell us where the maximum and minimum is. So I'm going to set that equal to 0, and then I'm going to solve for x. So 6x equals 4k. So x is going to be equal to 4k over 6, which is 4, which is 2k over 3, which is kind of what we've got here. Kind of what we've got there. Okay. So I think we're on the home stretch. So what do we do then? Well, we've got our equation up here that we know z. So we put k into that. Let's see where we go. So I'm going to just rewrite that. Z going to be equal to 3x squared, collecting like terms now, plus 2k squared minus 4kx. And that we've got rid of that. And now we're going to put this in wherever we have a x. So it's going to be 4k over 6 squared plus 2k squared minus 4k 2k over 3, isn't it? Okay, so when we multiply that out 3 times that, so it's going to be 2k, so 4k squared plus 2k squared minus, what is this, 8k squared over 3. Break. Play around with it a little bit more. Alright, well this one looks gruesome. My pen is glitching out, so it doesn't help either. Okay. So if y is that, k is a number. Okay, so k is a real number. Use calculus to show the minimum. So we're going to need to differentiate. Value of this, whatever that is equal to that. Okay. Well, this doesn't have a name, but we've got y in terms of x. So I'm going to call this, let's call it z. Okay. So we know that y is equal to a minus x. So therefore let's kind of work on this bit here. So 2k minus x squared is that bit there. And when we expand that out, I've got k and x, k and x, so we've got k squared minus kx minus kx plus x squared. So I've got k squared minus 2kx plus x squared, and we have to multiply 2 by that. Multiply this whole thing by 2. So we've got 2k squared minus 4kx plus 2 squared. So that's this bit here. I did that solely just to get rid of the y. So we can rewrite z now in terms of x and k. Remember, k is just a constant. So it's going to be x squared plus 2k squared minus 4kx plus 2x squared, and we've got like terms there, so 3x squared plus 2k squared, which is going to be constant. So when we differentiate that, that's going to disappear, and minus 4kx. Okay, so we want to find the turning point of maxima and minima. So we're going to find change of z over change of x, calling that k is constant. So in other words, changing k is 0. So that's going to be 6x, and this term here is going to disappear, and we're going to be left with 4k when we differentiate that. And now we want to set that equal to 0 and solve x, I guess. So 6x minus 4k equals 0. So 6x equals 4k. So x is going to be equal to 4k over 6, which is 2k over 3, which is nearly the same as that. So we know that we're on the right track. So now what do we do? So let's differentiate that again to see whether that's a minima or a maxima. So let's differentiate this. I'm going to differentiate with respect to x of this thing here. And 4k is a constant, so that's 6. So that's a number which is greater than 0, so therefore it's a minima. So there's a little proof that that's a minima point there. Okay, so now that we've got this, let's prove that when we put this into this equation, we get what we wanted to. So I'm going to move over here. So I've got 3x squared, which we don't want. We want 3 times 2k over 3 squared plus 2k square minus 4k 2k over 3 not square z. So when we expand out this this bracket, it's going to this thing here, 2k over 3 squared is going to be 4k squared over 9. Times that by 3, so it's going to be 12k squared over 9 plus, and I'm going to put it over 1 there because I want them over a common denominator, minus 8k over 3. So let's put them all over 3. So divide, this goes to 4, that goes to 3. So 4k squared plus 2k squared minus 8k squared all over 3, and that's going to be minus minus 2k squared over 3. We want to know, it's not. Where did I go wrong, kids? And have a think. I know where I went wrong. This thing here we need to multiply this by 3. So that should be rubbing out. One of those days. It's the end of the day. It's going to be 6 because 2 times 3 is 6. So this is going to be 4 plus 6 minus 8 is 2k squared over 3. And that is, yes, that's what we started with. That's what we get when we put this into this equation. We know that that's a minima. So there's our quote unquote proof. Not really a formal proof, but it's kind of an informal proof. And that's the end of that exam. So this exam was not fun. I didn't enjoy this one at all. Why they need to gab on and on about trucks and petri dishes and all of this other nonsense, I don't know, but they do. Some of the questions were kind of quite challenging. So I imagine if you really knew stuff, you'd do quite well. But if you didn't, I think you probably struggle. Quite a bit harder than the algebra exam, even though they're worth the same amount of credits. So swings and roundabouts, I guess. Anyway, I've got to edit this now. Wish me luck.